Hello guys, welcome back to part 2 of this video, AWSome Pipeline. Thanks for your support. My name is Amardeep Singh. In the first video, we talked about what is continuous integration and continuous delivery. We also learned about different AWS services available for CI/CD. If you remember from last video, we are developing a Spring Boot microservice, which we will be deploying into AWS Cloud on our EC2 instances running behind a load balancer. In the last video, we developed a Spring Boot application and we learned about AWS Code Commit, Code Build, Code Deploy, and AWS Code Pipeline. In case you have missed the first part of this video, I will leave a link in the description so that you can follow and learn a lot from that. In this video, we will be creating all the infrastructure we needed, and then we will set up our pipeline for continuous delivery. So let's get started. Hey, welcome back guys. Now we are logged into our AWS Management Console, and what we start doing is, first of all, in order to create AWS Code Pipeline, we need to create a role which can be used by our EC2 instances and assign Code Deploy and S3 full access to that role. So let's go to IAM console. So I will start typing here IAM. And let's go to the roles. And we are going to create the new role. And type of role we are creating is EC2, and next click on permissions. So we need to assign two policies to it. One, we need to assign S3 full access so that our role can have full access to our S3 file. So I typed S3 here and I'm selecting Amazon S3 full access. Next thing which we want to do is we want to give Code Deploy access. So Code Deploy agent can connect and integrate with Code Deploy services. So let's search for Code Deploy. So we can select here Amazon EC2 role for AWS Code Deploy. We selected it, click next, and we can say type is equal to code pipeline demo, and click review. And we need to give a role to this we need to give a name to this role. We can say EC2 code deploy or code pipeline demo role, and role description is fine. We don't need to change anything, and we can just click on create role. So now this role is created. We can see EC2 code pipeline demo role. Now we need to create one more role for our code deployer. So let's create another role, and this time we need to select the code deployer. So code deploy. So select this service, code deploy, and we selected here code deploy for EC2 instances. So this will allow our code deploy service to deploy our code to auto scaling group on our behalf. And next thing is permissions. So this is already selected. We just click on next, and we can say type. We can say code pipeline demo, and click next, and we can say so we named it code pipeline demo -deployer or role. So this is the role name which we have provided, and create role. So now what we have our two EC2 roles created here. One is used by the code deployer to deploy application to our auto scaling group which we are going to create. And another role is used by the EC2 instance which we are going to launch, and those EC2 instances will be running a code deploy agent, so that code deploy agent can communicate back to the code deploy service. And that's how the deployment is done in EC2 instances or in the AWS code deploy. There is an agent running on your infrastructure, your on-prem server, or on your EC2 instances, which is basically communicating back and forth with the service, code deployer service. So now we created two roles. Next step is to create a security group which we will be using by our EC2 instances. So let's go to the EC2 dashboard here. And what we want to do is we want to create a new security role. So move to the security groups here. So click on security groups, and what we are going to do is there is some already created, these existing. So I'm going to delete these security groups, we don't need them. Okay, so now we are on the security group screen. So let's create a new security group which will be used by our EC2 instances in order to allow certain traffic. So what I will name is code pipeline demo EC2 security group. Okay, let's say allow SSH and HTTP traffic. I'm keeping it into the default VPC. So I'm keeping it into the default VPC. Next thing which we need to do is we need to allow inbound rules. So what we want to do is we want to allow HTTP traffic, and we also should be able to log in through the SSH console. So what I'm going to do is I'm saying custom HTTP. So what I'm going to select in the role, I'm going to select HTTP because we want to allow traffic on port 80. And the source we are saying like anywhere in the world you can connect on the port 80. And another role which we are adding is we are going to add SSH, and this will open up port 22 for the connection. Here also I'm selecting anywhere. That is not a very secure way, but for the sake of this demo, anywhere should be fine. And now we have our inbound rules. We don't need to define any outbound rules because security group are, we don't need to define any outbound rule because we want to allow all the outgoing traffic, whatever is allowed incoming. So security group are stateful. So security groups are stateful. So whatever traffic you allow inbound, it will automatically go outbound. And let's create a tag. Type is pipeline demo. Code pipeline demo. I created this tag, and let's create this security group. So now you see it, our security group is created, and we allow incoming traffic on port 80 and 22. Now we have created our security groups. So as a next step, let's go to the load balancers tab and start creating a load balancer which will be front facing our EC2 instances. So I'm clicking here on load balancer, and we will start creating a new load balancer. So now I have clicked on the load balancers tab. Let's start creating a new load balancer. Click on create load balancer button here, and we are going to create an application load balancer. There are 3 types of load balancer here, or I will say 4 types of load balancer here, because one is the previous generation called classic load balancer, another one is network load balancer, and one is gateway load balancer. But we are going to create an application load balancer which runs on layer 7 and have more visibility. We don't need any specific need here, but let's create a application load balancer. So first thing, we need to give a name to this load balancer. So I'm saying like code pipeline demo load balancer, and we want it to be internet facing, and we want it to support IP4. We don't need IP6, but IPv4 should be fine here. And we want this load balancer to listen for HTTP protocol and port 80, and we can place it into 3 availability zones. We can do it for all, but I think 3 availability zones should be fine. We are using US East 1A, US East 1B, US East 1C, and we are leaving the default subnets. We are not doing anything. Next, let's go to the security group, and it is saying that our load balancer is going to be open for the world. You can customize it, so let's go. And what we can do is we can have a new security group created, and what we will do, we will be allowing the traffic on port 80. Either we can use some of the existing one, but let's create a new one, and what we will be naming is code pipeline demo load balancer security group. We are not changing the description, let's keep it by default, and we are keeping the port range as 80. We are not changing any rules. So if you see here, it is allowing traffic to be passed through from anywhere in the world. So this load balancer will be front facing our EC2 instances, so we want people to reach out from anywhere to these security or these ports. So let's click continue. Now load balancer wants us to define a target group so that it can start redirecting traffic coming to load balancer to this particular target group. So let's create a new target group, and we will name it code pipeline demo target group. And we say like our target will be EC2 instances, or we can define different targets. Either we can have a static IP defined here, or we can have a lambda function to be executed whenever any traffic is coming to our load balancer. But here we are fine with the EC2 instances. We are not changing any protocol and anything. We are keeping it by default 80, and it is asking us for the advanced health checks. Here success code 200 is fine. We are fine with the default HTTP protocol and path to be the root of our application. And here it is showing how much healthy threshold we needed or unhealthy threshold, when the timeout can happen and what intervals this health check will be checked. And success code for health check is 200. So if you have an application which sends status code different than 200, you can change it here. But for our case, we just have a simple REST service which will be returning 200 status code, so we want to keep it default to 200. So let's click register targets. Right now we don't have any EC2 instance defined yet, so it will not be able to find any instances here or register here. So nothing is matching our request and nothing is currently registered with it. We are fine with it because we will be creating those instances later. So let's continue to review. Now it is the information which we can review it. This is the name, this is internet facing, it is listening on port 80 for protocol HTTP, it is using IPv4, and security group name is this code pipeline -demo lb/security group, and routing, it is like new target group, port 80 again. So we are not changing any ports. So load balancer will listen on the default port HTTP port 80, and then it will target on the port 80 for our instances. So we are not changing anything here. So let's go ahead and create this target group and load balancer. It will take like few seconds. So now if you see, our load balancer have been created, and the name of the load balancer is code pipeline demo-lb. So let's close this. Now if you see, our load balancer is here. Next thing is our security groups are here, and our roles we have created. So far we have created 2 roles. One needs to be used by our EC2 instances, and another one is used by the code deployer. Then we created a security group which will be used by our EC2 instances, and we also created a load balancer and created a security group for the load balancer, and also defined a target group. So as a next step, what we need is we need to create an auto scaling group. And to create an auto scaling group, we want to define a launch template, basically, from which auto scaling group can load or create our new instances. So let's go ahead and start creating the launch template. So now we are in our launch template screen, our default screen. So what we need to do is we will create a new launch template so that we can define this launch template, and whenever our auto scaling group needs to create a new instance, it can use this launch template and launch our EC2 instances. So what is launch template? Launch template is definitely so launch template is just a template we define, a predefined AMI and some settings, and whenever an instance needs to be launched through this launch template, it will be identical to other ones created through this launch templates. So let's go ahead and create launch template, and it is asking for a name. So let's say code pipeline demo launch template, and we'll say this is the version 1, and let's add a tag here. We'll say type is equal to code pipeline demo here, and then source template it is asking. So we are not using any source template, but if you want to copy it from some existing code template or launch template, you can define, and that should be listed here, and you can copy over all the settings from there. But we don't have one, so let's go ahead, and what we want to do is we want to use this Amazon Linux to AMI, which is going to be a default AMI for us. So let's choose this one, and then we are going to use instance type as T2 micro, so that we don't have to pay any cost. It is free tier eligible, so let's use T2 micro here. And then it is asking the key pair to login. So each EC2 instance, if you want to log in through SSH, you need to define a key pair. So I have some existing key pair which I'm going to choose here. Then it is asking for the security setting and network setting. So I'm fine using the VPC which is default, and the security group. So now we need to assign a security group to it. So what we can do is we can use the security group which we defined earlier for this purpose. So I'm choosing this security group, and then storage volume we are fine, like default 8 GB. We don't want to add anything more. Network interfaces we are fine. Now go to the advanced detail. Okay, so I want to define a IAM instance profile. What is the IAM instance profile? Is basically a role you want to assign it to an EC2 instance which is launched through this launch template. So let's go ahead here, and this is the EC2 code pipeline demo role which we defined, which will have access to S3 and the AWS Code Deploy agent can communicate. So I'm choosing this. The next we need to define the user data. So basically user data is what, whenever you launch an instance, if you have some initialization code or some settings or update you want to download in the starting of your EC2 instance, that you can put into the user data. For this demo we need some details which we want to be available when this EC2 instance is launched. So one thing is we want to install Java on this host. We want to get the latest update for this Linux version. And also what we need to do is we need to install the AWS Code Deploy agent. So as I mentioned earlier, AWS Code Deploy service works with the agent, and so AWS Code Deploy service is agent based. You need to have an agent running on the each host where you want to deploy through the AWS Code Deploy service. So in this user data, we will be defining, first we want to install latest version or latest upgrades to our OS. Next thing, we want to download the EC2 Code Deploy agent. Then we need to start that agent, and also we want to install Java 11 on this host or this EC2 instance so that our application can successfully run on it. So I have those codes defined. So let me find. So I'm copying here some script. I will add this script as part of the source code. So this script is basically what it is doing. It is a bash script. First, it is trying to install the latest update for your OS. And next thing what it is doing, it is installing Ruby, and it is installing the wget utility, and then it is going to the home, user home, and then it is basically downloading the Code Deploy agent for US East 1. So you need to install it from a S3 bucket. So that's the reason the role which we created, we provided access to S3 so that it is able to download this AWS Code Deploy agent. Then it is installing this agent, and then it is starting this agent. Then after that, we'll removing this agent. And in the last step, we are downloading the Java or JDK 11 in our EC2 instances. So when the instance is launched, it is ready to use for us. So I will include all of these dependencies. Another thing which I want to highlight is if you are not in the US East 1 zone, you need to find the bucket for this EC2 Code Deploy agent, like in which region, in which bucket it is available. So if you look at here, these are the instructions how to install a Code Deploy agent. So first of all, you need to run an update in your OS environment, then you can install Ruby, and then you install the wget utility. And then if you have existing installation, you can delete it that, and you can get the AWS code agent from a bucket. So list of buckets will be available here. In which region, what's the bucket name, you can click here on this link, and this will give you the exact location. But these are the steps which we need to perform on any EC2 instance to install the AWS Code Deploy agent. So this is what I'm doing in the user metadata file. So I included that link to that page which has all of these steps, like how to install the AWS code agent. And this is what we are doing in this user data. So now we are done setting up everything in this launch instance. So let's go ahead and create this launch template for our auto scaling group. So now we have created this launch template. So now we are ready to go ahead and create the auto scaling group. So now we are in our Amazon EC2 auto scaling screen. So let's go ahead and start creating a new auto scaling group so that we can start launching our EC2 instances. So first of all, we need to give a name to it. So let's say Code Pipeline Demo Auto Scaling Group. And then we need to choose a launch template. So we have our launch template listed here, which we just created a few minutes ago. But if you are going to create a launch configuration, which is an older way of doing things, you can switch to launch template, launch configuration. But we don't have any launch configuration created. We are going to use the launch template. So I'm switching to launch template, and let's choose our launch template, what we have created. And it is giving us description like what all type of information we have selected there. And if something is not correct, if you think need to modify, you can click on this link and you can change the setting there, and that will create a new version, and you can select the what version you want to use it. So our default version is 1 for our launch template, so we are going to use the default version 1. So let's click next. Now it is asking like what all settings you want to do it. You want to customize anything, but what we are saying, okay, we don't want to change anything. Let's create whatever is selected in our launch templates. So let's click next, and it's asking subnet. So we can, so here it is asking like what subnets you want to launch your instances. So what we can do is we can select the same subnets what we have selected for our load balancer. So we selected US East 1, US East B, 1B, and US East 1C. You can select all of them, but for the sake of this demo, I'm just choosing these 3, and let's click next. And it is asking that what is the health check grace period time. So it is basically in the 300 seconds, which is basically 5 minutes. I want to reduce it just to 60 seconds. So within 1 minute, we can have our load balancer check for these health instances. And if we need to choose anything, we can still use that. So it is asking first thing like no load balancer, but we have a load balancer. So we can attach this configuration to our existing load balancer. And from this target group, we can select the target group which we have corrected. And health checks, we just modified it from 300 seconds to 60 seconds because we want our instances to become healthy soon enough, because we are not deploying any complicated like application. It is very simple. So let's keep it 60 seconds. It is asking if we want to collect the matrices within the CloudWatch or anything, but let's not choose or change anything. Let's continue. And it is asking what is the desired capacity. And as we talked earlier that we want to have this launch 3 instances, and we will be performing deployment on 3 instances. So I'm keeping this maximum capacity and minimum capacity and desired capacity, all 3. And then it is asking whether we want to change anything in the scaling policies, which we are not going to change. So let's keep it same, whatever it is. Add notification, let's skip this. We don't want to add. Tag, let me add a tag type which we are using in other resources also. Pipeline demo. So all of our new instances will be getting this tag type is equal to code-pipeline demo. If we uncheck it, our new instances will not be getting it. So let's keep it same. So now we are ready to create our first auto scaling group, and we are using the launch template which we created earlier, and we have associated this auto scaling group to our load balancer, and we define like what is our target group. So let's go ahead and create this auto scaling group. So our auto scaling group is done, and we set the desired capacity to 3. So what it will do, it will try to launch our EC2 instances. It will launch 3 EC2 instances, and if we try to, run the application, it will not be doing anything because we haven't deployed anything. What it will be doing, it will be pre-warming our EC2 instances. It will launch those instances. It will install the code deploy agent on those EC2 instances. Also, it will install the Java 11 on those instances, but we haven't done the deployment of our application. So our application will not be running on port 80 on these instances. So let's give it a couple of minutes. Once our EC2 instances are up and ready, what we will do is we will try to access those EC2 instances using their public IP. And we'll see like it will be throwing an error for us because there is no service running on port 80. So let's give it a minute. Once the status checks are successful and EC2 instance status change, we will go ahead and try connecting to those. Now let's refresh and see 2 of our EC2 instances are healthy and another third one is still launching. So let me name them EC2 1. So it is not required, but I'm just naming them so that we can differentiate between these 3. 2, Now you see all three of our EC2 instances are up and running and they pass the health checks. So now what I will do, I will go ahead to the one of them, copy the public address of this, and what I will do, I will try to click on it, copy the public IP address, and we try to access this EC2 instance. So here nothing is coming, it is saying refuse to connect because there is no service running on port 80. We just have our code deploy agents installed, we have our Java installed, but we haven't deployed our service, so nothing is running on this EC2 instance. Next thing is, let's go ahead and click on the load balancer and we will try to access the load balancer DNS name. So this is the DNS name of the load balancer. Let's go ahead and click here and try to access on port 80. It is giving like 5 bad gateway. So what it means is our load balancer is running and it is listening for traffic on port 80, but when you try to redirect that request to the target group, there is no EC2 instance can handle this traffic. So it is giving like 5 bad gateway error. If you remember the architecture diagram we discussed earlier, we are done with half of this. So we are, as a client, try to access the service on port 80. So right side is pretty much done. So if you see as a client, we try to access the service on port 80, which is giving us an error and saying like bad gateway, and request was reaching to application load balancer and EC2 instance is launched but not able to handle the traffic. We created auto scaling group also. So right side of this diagram is done, which is basically runtime environment of our application. Now we need to focus on the left side of this diagram, that how we will be able to make changes to our application and that application can be deployed to these EC2 instances with the help of AWS Code Pipeline, and we will be using AWS Code Build and AWS Code Deploy services. So let's start focusing on the left side of this diagram. But before we do that, what we need to do is we need to go ahead and create a GitHub project for our project. So what I will do is I will go ahead and open my GitHub account. So now I'm on my GitHub account. So let's create a new repository. And what we are going to name is, I will say Code Pipeline Demo. So this name is available and we are going to create our new GitHub project called Code Pipeline. And we are going to make it as a public repository and we want to add a readme file. So we are adding a gitignore file to it, and we can add a template, and template we can say Java. So, and we are choosing a license we can choose as Apache license 2.0, and now we are ready to create our new repository on GitHub. And what we are going to do, once we create this repository, we have some source code which we developed in our last video, and we will be setting up this remote repository so that we can push that code into this repository. So let's create this repository. Now our Code Pipeline Demo repository is done. So as a next step, what I will do is I will go to my terminal. I will go to my source code directory where I have created the project. So now I open my terminal. So let's go to the directory where I have my source code, which is in Code Pipeline Demo. So what we need to do is, now we need to initialize this remote repository into our local directory so that we can commit that code. So let's git init, it basically initializing the git repository in our branch. And now what we are going to do is we need to add the remote repository. So git. So now what we are doing it, we first initialize our local directory as a git repository. Now we are using this command to add the remote repository in our local directory. So now we should be able to see what all changes which we have. Let's say git status, and we are going to add everything whatever we have in our local repository. So let's git add, and I'm doing star. It added everything, and let's check git status again. So it has everything added, and
So now our remote branch is set up. Let's try to push the changes. So first I will say git commit -m, say initial commit. Now let's commit these changes, and we will do it git push set upstream origin master -f. So -f we are using because we want to fast forward and merge our changes with the changes which we already have in the repository. So we made, and it says it's already up to date. Now let's go ahead and refresh the code repository here, and you can see our source code changes are committed now here. So what we need to do is we need to start setting up our code pipeline in our AWS environment. But before we do that, we need to create a file called buildspec.yaml. So what that file does is, so let's search in Google, and I will leave this link in the description. This is a build spec sample file. So what it does is this file basically define or gives indication to our code build service that what all changes or what all command it needs to run in order to build your project. So you need to supply this file. So there are two modes which are done. Either it can be done through commands or it can be done through supplying this file. So if you see the sample file, it says like, okay, it has like different phases. So in the install phase, what runtime versions you need. So it say like Core 11. So basically it needs the Java 11 version. In pre-build, it is just running a command and it is just saying, okay, echo nothing to do in this pre-build phase. So you can basically print anything, whatever you want. In the build phase, it is basically running the Maven install command, and post build, it is basically saying that build completed. And in the artifact phases, you can define what files you want to supply as your artifact, because when your application will be building, it will be generating some artifacts, and those artifacts can be used for the deployment. So let's go back to our source code. So we are in our code pipeline demo. So what we need to do it here is, let's go ahead and create a new file called buildspec.yaml file, and it needs to be in your root directory of the project. So what we will do is I will copy some code over, and we'll explain what this buildspec file is doing. So now I copied this buildspec code, and you will see it is using version 0.2, and in the phases we have install phase, we have build phase, post build, artifact, and files we are using for artifacts. And then it is like discard path, yes. So what we are doing, we are using Java 11, and this is the template you can use and copy paste in your Java projects. And in the build phase, we are using command build start on date, and it will print the date. And then we are using Maven test, which is basically run some test cases on our application. And the post build phase, we are running the Maven package. So Maven package command what it will do, it will generate the jar file which we need for our. So in the artifact section, what we want to do is we want to use our generated jar file as our artifact, and also we want to package in appspec.yaml file, which will be used by the code deploy or AWS code deploy to identify where it needs to deploy and what commands it needs to run in order to deploy the application. Then we have a scripts folder, which we haven't created yet. So let's go ahead and create a scripts folder. And also let's go ahead and add a appspec.yaml file. So now we are done appspec.yaml file and buildspec.yaml file. What is going to be in the appspec.yaml file? That link also I will share. So if you go ahead and click on this reference appspec.file, you can see there are different stages through which this appspec.yaml file will run. And here is the spacing, and here is a sample of file. So what you can do is you can have different hooks: before install, after install, application start, application stop, and you can run different scripts within your application. You can set the timeout, and you can send as a what user it will run. So what we are going to use, we can define the different scripts, and we are going to use this AWSome file as a sample. So let's go back to our source code. So in this AWSome.yaml file, I'm going to paste this. So what we can have it, permissions we are changing to 7.755, and our owner is EC2. And then there are application hooks we can start, like application start, application.stop. So what we have is star.sh. So now we have our application, and that's very simple version of it. Like you can have different hooks: application stop, application start, before installation, validate service, but we are not doing anything. So we just need a star.sh. And if you look at here in the star.sh, what we are going to the home directory of the user, and we are starting our file or our jar file as a service on port 80. So our application boot or Spring Boot application will start as on port 80. And next thing is what we are doing in the appspec.file is stopping this service. So in order to stop the service, what we have it, we are killing all the Java processes on our service, and also we are removing this code pipeline.jar file. So we are removing this file, and we are removing the appspec file from it. We are removing the app.log file, and we are using that deleting any SSS file from here, and then we are exiting. So let's save this thing, and now we have our appspec file defined here. We have two source code file, and this agent.ss is where we use for the user data. So it is installing our server, doing this thing, and you doing that thing. Now look at the pom.xml file for our service. So what we need to do is we need to use as a final version. So it is using code deployment pipeline demo, and what we need to use is a final name as code demo, pipeline demo. So this is what we are going to do it here. So we need to use this code pipeline demos. We try to build it, run as, and we are running as a Maven build. It should deploy, it should create a code pipeline demo file. And if you see here in the target directory, so it has generated code pipeline -demo.jar. And this is what we are using in our buildspec.file. This is what we are using as a target. So this is what we are using. We are going to, in our build.spec file, we are going to use target/code pipeline demo, which is this jar file. Then we are using this appspec.yaml file, and then we are using this script/hyphen, which has like just start and stop script. Agent.ss, we don't need it here, just for the reference I'm using it. So now we are done, and let's start this application on local, and what we can do, we can see that what is the response coming is. So if I start it here, and it is saying hello microservice is AWS cloud. So basically our service is done, and we can close it. And as a next step, what we need to do is we made some changes into our code. So let's do one thing. Let's see, get status, and let's get add star and get push. Added build. Okay, so now everything is checked in, and we can see it here in our GitHub account, in our repository. So if you see here in our GitHub repository, refresh it, and you can see this appspec and buildspec file is already there. Now we are all set up. From as a next step, what we need to do is we need to start creating a pipeline here in our AWS environment. So what we will do is go back to and search here AWS. You can start searching here code pipeline. Let's go there. And to create a pipeline, what we need to have it, if you see the left side, it is in the developer tool, you have source, artifacts, build, deploy, and pipeline. But in order to have a pipeline, what we need to do is we need to create a deploy project and we need to create a build project. So first let's go into the build and click here, build projects. We don't have any build project, so what we need to do is click on this create build project, pipeline demo. This build project will, now we don't need to enable build batch, we don't need to restrict anything. Source provider, so this is from where we will be getting the source for our build project. So we'll be getting it from the GitHub. So just choose here GitHub. You can use the AWS code commit service which we talked about earlier. You can use Amazon S3, you can use Bitbucket, but here we are using the GitHub. So let's use GitHub. It is saying build public repository, or you can repository in my GitHub account. If you say GitHub repository in my GitHub account, my account is already linked and you can get the project which you want. And here I will say public repository and it will ask the repository URL. So let's say connect this one, okay, and go to the, and it is already connecting to GitHub using OAuth. If you are not connecting, you can disconnect and create here, okay. And source version is fine, we'll say master branch we want to get our, or you can give the commit ID also. Manage image, let's use the operating system. We are using Amazon Linux 2 in order to create our build project. And then runtime we can use standard, and image we can use standard 3.0. environment is Linux, and it is asking for a new service role, which we should be fine creating a new service role. We don't need to use existing. So let's use a new service role which code build service will create for us. And then we don't need to, so we are saying like use a build spec file, or we can insert commands also. So maven clean install, like that we can use it, but we don't want to use it. So what we can do is we are going to use the build spec file which we have specified earlier. And artifacts, let's not choose anything. We in the build spec file we already defined our artifacts, so we are not going to do anything. We can configure and use CloudWatch logs, but let's not do anything because those logs will not be productionizing this application, so I'm not choosing anything. So you can use S3 logs, you can use CloudWatch logs. So let's just go ahead and create our build project. If you see here, what we have done is we have created a build project with this name code pipeline. It is using manage image, and if you want you can use a custom image also. If you want you can bring your custom images and you can specify a Docker image, so that's why it is very customizable. But we are going to use a manage image and on Linux, and runtime is standard, and the image which we are using is the latest one. Okay, and we can always use the latest version for runtime environment. Environment time is Linux. It is going to create a new role. So it will take a couple of minutes in order to create this build project.
So now we have created our code build project. It is time to go ahead and look at the build. So as soon as you start your first build project, it will try to automatically build it, and you can see the status here. Our build is successful. That means our settings for this projects are working. AWS Code Build service is able to connect to our repository in GitHub and able to download it, and it was able to successfully build this project. As a next step, what we need to do is we need to go to Code Deploy service and we'll try to create a Code Deploy project. So let's go there and the getting started page, and we'll try to create an application by create application. So let's click here, and it is asking the details about our application. So what we are going to do is code pipeline, and compute platform we are going to use is EC2 instances, because we already created three EC2 instances and running behind our load balancer. So we want to deploy our we want to utilize this code deploy application to deploy to our EC2 instances. Other way is you can select AWS Lambda or Amazon ECS. So code deploy service can deploy in any of these platforms, and not just EC2 instances, it can deploy to your on-premises instances also. So let's select this and let's click on create application. Now we have created the code deploy application. As a next step, what we need to do is we need to create a deployment group. You can create multiple deployment groups. Suppose you want to deploy the same application into your dev environment, in your test environment, or in your production environment. So you can have different deployment groups. So let's create a deployment group, and I'm going to name it code pipeline demo deployment group, and it is asking for a service role. So we already created a service role initially. So this service role has permissions to deploy to EC2 instances. So what it is going to do, it is take the artifact generated in the build phase, and then it uses those artifacts to deploy to our EC2 instances. So let's select this service role, and what we are going to do, there are two types of deployment type: either in place, where you want to replace the service or your microservice or your code on the existing EC2 instances. Another one is blue-green deployment. So blue-green deployment is basically you install your application onto the new service or a new set of instances, and then once you think it is looking good, everything is up to the speed, you are looking to replace those old instances with the new instances. But for sake of this demo, we are going to choose in place. We want our existing application to get modified. And also we can select how we want to deploy. So there are multiple ways. One is you want to deploy onto your auto scaling group, which we are going to do it here. Another thing is you can directly select the EC2 instances where you want to deploy, and you can use the tag which we assign to our EC2 instances. So that's the reason the tags are really important. So you can target specific tags, and only those EC2 instances will be having this deployment. But for the sake of this tutorial, we are going to target an auto scaling group. Another form is you can target your on-premises instances, and that also you can define using the tags. But here we are going to type auto scaling group, and we are going to deploy our application to an auto scaling group which we created earlier. Let's select it, and now it is going to give us an option what auto scaling group you are going to deploy. And if you select here, there is only one auto scaling group in our account which we created earlier in this demo. So let's select that. And now we have selected this auto scaling group. If you have multiple auto scaling group, it gives us option to select multiple here. But we only have one auto scaling group in our account, so let's target this one. And we know like there are 3 EC2 instances running behind this auto scaling group. So if you see, it is showing it here also, like how many matching instances is found. So it is saying 3 unique matching instances you have it. So we are going to target our application deployment to on these 3 unique match instances. Now another thing is what is our deployment setting. So if you look at here, you can have a different setting, like you want to deploy your code only one instance at a time. So this is a good choice when you want to have a rolling kind of deployment model. Another is half at a time. So if you are running a 4 EC2 instances, it will try to deploy your code or 2 instances at a time, and once that is successful, it will proceed to deploy on the remaining. But for sake of our demo, because we are not running any production level instances, we want all of this job to finish quickly, so we are going to target all at once. But this is not a recommended setting for the production environment, because you will be having some outages, because code deploy will try to deploy these EC2 instances at the same time. Another thing is select a load balancer. So we already have an application load balancer which we created earlier. So what we are going to do, we are going to select a target group for that load balancer, and we created that target group as code-pipeline demo or -tg. So let's select this one. And now there are some advanced settings. So you can set up some triggers which you want to do on certain events, or you can select some alarms, and you can enable or disable rollbacks. So we are not going to enable any of these settings here, because we just want to demonstrate that how you can create a code pipeline and you can deploy using code deploy tools. So let's create this deployment group. Now see how easy it is to configure a code deploy. So now we see it, we created a code deploy project, then we created a deployment group here, and which is going to target our auto scaling group. And there are 3 instances running behind that auto scaling group. So as a next step, what we need to do is we have our code build service, we have our code commit repository, which is basically GitHub in this case. And now what we need to do is we need to plug all this in together. And how we do it through the code pipeline, and that's the basis for this demo, that from committing a line of code change, how it can be automatically built and deployed. So let's click on the code pipeline and click on the getting started page. So now what we are going to do is we are going to create a new pipeline. Let's click on this create pipeline button. Now it is asking for a name for our pipeline, so say code. Now it is asking if we want to create a new service role or we want to use an existing role. So we'll let it create a new service role because we don't have any existing role for this code pipeline, so I will leave it as it is. And then it is allow AWS code pipeline to create a service role. We check this option, so as soon as we select this role, it will try to create that role. Now it is asking who is the source provider. So the way pipeline works is you create the basic structure of your pipeline, and then you plug in different sections of that pipeline. And we know like our source code provider is GitHub. So let's select a GitHub version 2, selected it, and it is asking what is my connection to the GitHub. And I can use this existing connection which I already created in my account. But if you are looking to, or you are first time creating this pipeline, you can connect to GitHub using this. What it will do, it will pop up and it will authenticate it against your AWS environment or GitHub environment, and you can select the connection name and then try to connect. But I'm not going to do it because I already have an existing connection. So I'm saying, okay, use GitHub teach me more GitHub connection, and as soon as I connect to it, it will try to list all my repositories here. If I click on this button, it is listing all of my existing repositories what I have in my GitHub account. So we are using this code-pipeline demo. Let's select this one, and then it is going to ask me what branch I want to target. So my latest source code is available in my master branch, so I want to target master branch. But if you have a feature branch or some other type of branch, you can select that too. Now another thing what it is asking is, it is asking me about the hooks. So as soon as I commit something to my source code repository, it will integrate with it and it will automatically start my pipeline. So let's keep it enabled. I don't want to change it. And what it is asking is code pipeline output artifact format. So I will say code pipeline default. I'm not going to change it. So let's click next. Now it is asking, so now we have configured our source stage. So as we all know, and if you have worked in the Jenkins pipeline and all, pipeline is basically set of stages. So you configure different stages which makes your pipeline. So we already configured our source stage, that how we will be getting the source. Now next stage is the build stage. Once you download the source code, what you need to do is you need to compile it, you need to generate artifacts out of it. So this is the build stage. And since we already created a AWS Code Build project, so we can select that. So what it is asking is, you want to have a AWS Code Build as a build provider, or you want to add a Jenkins. So it is very easy for code pipeline to integrate with Jenkins, or you can use the AWS Code Build. For this demo, we are using AWS Code Build because recently we created a Code Build project. So let's select AWS Code Build. So as soon as you select it, you can change the region if you have your Code Build project in a different region, but we have created in the same region. So now as soon as we click on this project name, it will going to populate our existing code build project. So it is showing that this is the project which we created earlier in this demo. So you can select this one, and if you haven't created one, you can click on this create project and it will navigate you through the code build screens, and you can create a project there. Select this one. Now it is asking what is our build type. We want to build in the batches or we want to trigger a single build. So code build is really scalable. You don't have your builds to wait. So if you trigger multiple builds in parallel, it is going to accept those. Or you can select here that you want to wait for certain time period and then you want to start your builds. If you have any custom environment variable you want to pass on, you can pass on by clicking on this add environment variables. But we don't have anything here, so let's click single build and click next. Now it is asking us about our third stage, which is deploy provider. So now we have our source code, we build that source code, certain artifacts have been generated based on the configuration what we have in our build spec file. Now third step is to deploy this artifact to our targeting auto scaling group. So what we need to do is we need to supply here what is our deployment provider. So as you know, in AWS you can deploy different ways. You can have AWS Cloud Formation, you can have Elastic Beanstalk, or you have Code Deploy, and there are other different ways as well. You can deploy from Amazon S3 as well. But for this demo we are going to use AWS Code Deploy. So let's select AWS Code Deploy, and behind the scene AWS Code Deploy uses app spec file to determine as soon as this code deploy agent start working what instructions it needs to execute. And there are certain hooks in that, like validate your service, starting your application, stopping your application. So now we have selected AWS Code Deploy. We are going to stick to North Virginia region. Next step is to select the AWS Code Deploy project. So just few minutes before we created this AWS Code Pipeline demo Code Deploy project. So let's select this one. And now it is asking about the deployment group. As I mentioned earlier, you can have multiple deployment group within a AWS Code Deploy project. So the deployment group which we created was code-pipeline-demo-dg. Let's select this, and this is targeting our auto scaling group, and we have 3 instances where we want to deploy. Click next. Now it is asking us to review the information. If you look at it here in the pipeline setting, we are going to create a new role, which we are fine. And then it is talking about the pipeline artifacts. So whatever you generate the artifacts in the code build step, artifacts will be uploaded to Amazon S3 at this location. And the next step is the source stage. So basically from where your source code will come in. So our source code will come from a GitHub repository, and we have the configuration for this repository, and we are going to use the master branch. Next step is to building this source code, and we are going to use existing project, and project name is code-pipeline demo-build project. So as soon as our code is pushed to in our repository, this stage is going to kick off and start building our project. Once the artifacts generated, our deployment stage will start, and we'll try to deploy it using this deployment group into our EC2 instances. And there are 3 EC2 instances running in our account behind that auto scaling group which we have selected. So let's create this pipeline, and then we'll see that as soon as we create it, pipeline will start and try to build this project and try to deploy this project. And if you go, I will show you the different steps within the pipeline. So now you see, you can see like how this pipeline visualization is. The source code is just started, it is in progress, and the build is also started. As soon as the source stage is done, then build will start and the deploy will start. And once deploy is done, we are done deploying our service. If you see, just now source code step is completed. Now it is in the build phase, but until it is loading, what we need to do is let's go and take a look at our EC2 instances, what it is there. So I'm going to select EC2. Now we are at our EC2 management console, and we know like there are 3 instances running. but there is nothing deployed on EC2 instances. And when we try to go to our load balancer URL, so we are running these instances behind a load balancer URL. If you see here, all the health check will be failing because there is no service running on the EC2 instances, and we have this DNS name. We copy this one, and if we try to go to the console, we should be getting a error here. So it is giving us 502 bad gateway error because our load balancer is running fine, but it is not able to connect to our EC2 instances on port 80 because there is no service running on our EC2 instances. So if our deployment is successful, we should be seeing our web service response here. So let's look at our pipeline. Here we see source code is successful, build stage is successful. Now we are running into our deployment stage. So deployment stage will take some time because it has to go through certain steps. First it has to stop the traffic, then it is going to start the application, stop the existing application on the port and on our EC2 instances, and then they will try to start the application. So let's go and take a look what are the different details related to that and what all steps it has to go through. So this is our deployment stage. If you see here, it is trying to deploy, and these are our 3 EC2 instances. So it is trying to deploy all of these 3 EC2 instances at the same time because that is the setting we selected earlier. I don't recommend it for the production use because it will immediately create an outage for your application because all of your EC2 instances are going under the maintenance. So if you see here, let's click on one of these EC2 instance, and its status is showing in progress, and the event it is going is block traffic. Let's click on the view events because it goes through a different event phases for the deployments. Let's click on view events. So if you see here on the deployment model, it is first trying to before block traffic. This is one of the event. Then it is going to block the traffic for that particular EC2 instance. Then the after block traffic, then it will stop the existing application. In our case, there is no application running, so it is not going to impact us. And then it will try to download the bundle, which is basically copying over your artifacts from your S3 to the EC2 instance. So all of these events are happening through the code deploy agent, which is running our EC2 instances. So basically how the code deploy service deploy your source code to those instances. We have a AWS Code Deploy agent running on our EC2 instances, which communicate through this service, and it try to perform all of these actions, and these status are getting updated back into our code deploy service. So as we see, before block traffic took just less than 1 second, but block traffic always takes about 2 to 3 minutes, at least on the first deployment. After subsequent deployment, it goes a little bit faster, and then it will go to after block traffic, then application. So all other steps goes really fast. So only steps takes time is block traffic and allow traffic. So basically it checks and wait for the application to start up and make sure the endpoints start getting better and health endpoints are working fine, then only it will allow the traffic. So I'm going to pause this until we have this application run and deploy, or we have a fail. So we will see all the details status right here, and it will give us a reason why and deployment is failed, or if it is successful, it will give us a confirmation. Then we will go to our EC2 management console, and we'll see each of our instances have the application deployed and running it on port 80. We should be able to get a successful response from each of those, and then we can go back to our load balancer endpoint, and we should be able to access our microservice. So what I'm going to do is I'm going to pause it for a few minutes until deployment is successful. Now you can see this block traffic is successful, and it took about 5 minutes and 30 seconds. So this is the longest step where it tried to stop the traffic from load balancer to go to the each EC2 instances. And after that, you see it, all other steps took like less than 1 second. So if we look at the application stop, it is just couple of lines of script it runs, so it runs it very fast. And then there is a before install, install, after install, and application start. So the application or app spec file which we have in our source code repository, so if you look at here, you can have several hooks in this, but we are using only application start and application stop. But if you see at the console here, there are several hooks, so you can use any one of them, whatever you want. But for the simplicity and what we needed for the simple application, we are just using application stop and application start. So basically, if you have an existing application running, application stop, we are trying to stop the application first, and once application is stopped, we are trying to install that application again. Basically, whatever the artifact have copied over to the EC2 instance, we are just trying to run that Spring Boot file. But all of these steps or hooks are available for us as a developer. You can feel free to use any one of them. So now we see that our application start step is successful. It is now allowing traffic. So now it just completed and traffic is allowed on port 80. Let's go back to our EC2 management console, or let's first go back to the deployment, and we'll see that all of the EC2 instances are deployed. So we will see here all 3 EC2 instances have been deployment successful, and it is status is succeeded. And first one took about 8 minutes and 12 seconds, another one also took 8 minutes 12 seconds, the third one took almost a 30-40 seconds, little less as compared to others. So at this point, we should have our application deployed to EC2 instances. So first I will go and click to this endpoint. So this is our load balancer endpoint. Earlier it was giving us 502 bad gateway error, but right now we know our deployment is successful. If I refresh this page, I should see a response from my microservices coming back. So let's refresh it. And you see hello microservices in AWS cloud response I'm getting back. That means my application is successfully deployed to my EC2 instances. So now what I can do is I can go to the individual instances and I try to see it. All 3 of them are running successfully and I'm able to connect. So let's go to the EC2 instance 1, and here if you look at the public IP address, so I'm copying it, and if I paste it here, it should also give me the same response if my deployment is successful. Look, so I'm getting this response. That means my first instance is running successfully and it is responding to the user request. So what we have done so far is we have created an application or a Spring Boot microservice in our local. We supplied the app spec file, which is used by Code Deploy to determine, and what we have done is in this file we just provided where our source will be and what is the destination we want it to copy. So when the Code Deploy services start, it looks for the artifact at this location, and then we change the permissions. We give a 755 permission to our EC2 user, so our EC2 user is able to run the commands which are located in star.sh and stop.sh. So in the application start, we want to run this star.sh script, and when application stop, we want to stop this sh file to execute. And if you go to in the scripts folder, we have 3 scripts. One is star.sh, which is basically just going to the user directory, and then it is trying to run this command, which is basically a Spring Java command to run a Spring Boot. So what we are doing is we are making sure we are running this command from the Java process and -jar, and we are executing our application on the port 80. If you have defined it in the application.properties file, you don't have to specify here, but just to be sure that our process start on port 80, we are doing it. The reason why we are using port 80 is because we allowing traffic to reach to our EC2 instances on port 80, and our load balancer is also listening for a health endpoint on port 80. And the next, in the stop step, what we are doing is basically we are doing some cleanup, because those files have, first we are trying to stop all the Java processes. So if our application is running, we are trying to stop it. Next, what we are doing is we are deleting this code-pipeline demo.jar file from the home of the user, EC2 user, because these all files have been copied over there. If you try to deploy the next version of your file, and if it is already there, you might have conflict in overriding it. So we are doing that, all of the cleanup. Now agent.sh, this is the file which we needed into the user data field in our EC2 instances. So whenever our new EC2 instance is launching through our auto scaling group, it is basically going to execute all of this script again. So I will check in all this code. It is available on the GitHub. You can look at this file. So what it is doing, it is updating your OS to the latest updates. Then it is installing Ruby. It is installing wget utility so that you can get the code deploy agent, and it is changing the permission, and it is basically installing that code deploy agent. And then it is basically installing the Java 11, because that is a prerequisite for your application to run. You need to have Java in order to run a Spring Boot microservice. So the core part of this to work is to have this code deploy agent available on your EC2 instances. So it is not just for EC2 instances. If you are trying to deploy through code deploy on your on-prem servers, you need to have this agent running on that service. And for each region, you can install it from that particular bucket. So wget is basically utility to get a binary from this location or this bucket. So now what we have done it, we have created a Spring Boot application. We have deployed it through AWS Code Pipeline. Now next step, what I want to make sure is, like, it is not just one time deployment you have done it. Let's try to do is a continuous deployment. So what I will do is I will change the response for this microservice and will try to push these changes. And once we push these changes, it should automatically deploy, and within a few minutes we should be able to see the new version of our application on this load balancer URL. So right now this URL is saying hello microservice in the AWS cloud. Now we will say hello microservice in AWS cloud version 1.1, so that we are showing it like our latest changes are getting deployed, and it is continuous deployment. We don't have to make any changes into the AWS console. It should be all automatic as long as we are able to push our code to our repository. So let's try to make that change very quickly. So what I will do, I will go to this welcome controller, and I will make this hello microservice in cloud, and I will say dash version 1.1. So this is not a full-fledged application, just a demo purpose we are using it. So now what I will do is I will try to commit this source code, because we made this changes. So I will say git add star. So what I will do, git commit -m, and I'm putting a commit ID or commit information, that deploying enter. Now what I need to do is git push. So let's first, before I do git push, let's go to the code pipeline, and we'll see that our pipeline first version or first deployment was successful. So it sees our deployment ID is this, and status is successful, and the deployment type which we use is in place. So it creates some outage because we are trying to deploy all of that at once. Now what I will do is I will push this change, and we should see our pipeline is running again and trying to deploy our changes. So let's do git push. So now it pushed our changes to our GitHub repository master branch, and within a moment or we should see that it is trying to make another deployment. So now you see in our pipeline, as soon as I push the changes, code pipeline demo and most recent execution status starts showing in progress. So what we can do is we can click here, and we can go and look at the different stages it is running. So source stage just succeeded. Now it is in the build phase of this pipeline. If all of three of these stages are successful, if we go to our load balancer URL, we should be able to see hello microservices in AWS Cloud version 1.1. So if you see the right side here in the pipeline stage, source is successful. Now it is in the build phase, and once build phase is successful, it will go and start running into deploy phase. So see, just now the status change, our build phase is also successful. Now we are in the deploy phase of our pipeline. So I will click on the details and it will repeat the same process. It will first try to stop the traffic. Let's click on the view details. First it will try to block the traffic from the load balancer, which I said like it takes a little bit time. First time it took about 5 minutes and 30 seconds. Let's see this time if this time is reduced. Now you can see that deployment is successful, and this time in the block traffic it took about 5 minutes and 1 second, so 29 seconds less than the last time. I think it is getting better over the time. Now it is deployed on our EC2 instances. Let's go back and try to refresh our load balancer URL and see if we can see the latest version of our application. So if I'm refreshing here, you can see it starts seeing hello microservice in AWS Cloud version 1.1. Now our pipeline is successful, and you can see we are able to continuously make the deployment to our EC2 instances. So as a next step, what you can do is, if you have multiple environments, you can add and add it here. So suppose if you want to add it, you can come back here, and you see there are 3 stages currently. If you want to add another stage and say deploy to QA, or you can easily add different stages. So it is not just you have to have source, build and deploy stages. You can deploy to multiple environments or multiple deployment groups, and you can configure those stages. So I have shown in this video that how easy it is to configure AWS Code Pipeline and utilize services like Code Deploy and Code Build. And also we talked about earlier about code commits. So AWS made it really easy to deploy these microservices to the AWS Cloud and EC2 instances. Now we're done with our demo, so you all understood. So you can download the source code at GitHub, and I will leave this link to the description of this video, or you can type in github.com/teachmemore and code pipeline demo.
Thank you all for making to the last of this awesome pipeline video. Please don't forget to subscribe and like this video. Please subscribe to my channel. You can also connect me over LinkedIn and follow me on Twitter.